Traffic lights aren't random. They are reacting to you. We've all been there, sitting at a deserted intersection at 3 a.m., staring at a red light while not a single car passes in any direction. It feels like the machine is mocking you. It feels like a dumb timer counting down into infinity. But in most modern cities, that light isn't just a timer. It's a node in a massive living network. It's listening to the pavement, watching the flow of traffic, and making split-second decisions to prevent the city from grinding into a halt. Today, we're looking at the hidden intelligence behind the red, yellow, and green. Hey everyone, welcome back to the South Era Network. This is Tech Talks with Hasnan. Today, we are stepping in to look at one of the most successful automated systems in human history, the traffic signal. We're going to explain the magnets under your tires, the cameras above your head, and why the green wave is the ultimate goal of urban engineering. To understand how traffic lights think today, we have to understand where they started. For decades, traffic lights were fixed-time systems. They operated on a simple mechanical clock. Whether there were 10,000 cars or zero, the light stayed green for exactly 30 seconds and red for 60. In many older parts of the cities, these systems still exist. They are programmed based on historical data. Engineers know that at 8 a.m. on a Tuesday, Main Street is busy, so they manually set a longer green light for that window. But as soon as an accident happens or a special event occurs, these dumb timers become the primary cause of a gridlock. They can't adapt to it because they have no senses. They are blind onto the reality of the road. Now, if you've ever noticed a faint rectangular outline in the pavement as you pull up to a stoplight, you have seen the ears of the traffic signal. These are the inductive loop sensors, and this is where tech gets fascinating. It's not a weight sensor. The light doesn't care how heavy your car is. Instead, it uses electromagnetism. Beneath it is a coil of wire with an electrical current running through it, creating a magnetic field. When your car, a giant hunk of metal, pulls over that coil, it disturbs the magnetic field. This change in inductance sends a signal to the controller cabinet on the sidewalk saying there's a vehicle in lane number 4. This is why if you stop too far back from the line, the light might never change. In fact, this happened to me on my drive over to this studio, where I stopped my car a little too far from the red light and it never changed to green until I pulled a little forward. It's simply because you haven't tripped the magnet. It's also why motorcycles sometimes get stuck at red lights because they don't have enough metal to trigger the sensor. And that is why sometimes many bikers attach powerful magnets to the bottom of their frames just to talk to the road. Now, as we move on to 2026, many cities are moving away from cutting holes in the ground and instead putting eyes on the poles. If you look at the top of a modern traffic signal, you'll often see small squares of black cylinders. These are video image processors and microwave radar. These systems use computer vision to analyze the scene in real time. Unlike a simple magnet that only knows if a car is there, those cameras can count how many cars there are in a line. They can distinguish between a bus or a bicycle or even a pedestrian. If the camera sees a line of 20 cars backed up, it can communicate with the central computer to extend the green light by 10 seconds to clear the queue. This is actuated control, and it's the difference between a smooth commute and a frustrating stop-and-go nightmare. The real magic happens when individual lights stop acting alone and start acting as a network. This is managed by a system called SCATS, Sydney Coordinated Adaptive Traffic System. It's a big word. I can just write it down. Or similar AI-driven platforms. Engineers try to create what's known as the green wave. If you drive at exactly the speed limit, say 40 miles an hour, the system calculates the distance between intersection and times the light so that as you arrive the next one, it turns green exactly as you get there. This isn't just for your convenience, it's also for the city's health. Every time a car sits idle at a red light, it wastes fuel and increases emissions. A perfectly timed green wave can reduce a city's carbon footprint by up to 15% without changing a single engine. The lights are talking to each other, passing the information of traffic down the line to keep the momentum moving. We've all experienced the frustration of lights that turn red just as we arrive, or a side street that gets a green light for one lone car while 50 cars on the main road have to stop. Often, this is due to preemption and priority. Let's talk about emergency preemption. Fire trucks and ambulances are equipped with specialized IR emitters or GPS triggers. As they approach, they send a high priority command to the light, forcing it to turn green immediately. Next up is transit priority. Many cities now give buses and trams a head start. The signal light will detect a bus and give it a 3-second green light before the rest of the traffic to keep public transit on schedule. If you're stuck at a fairly long red light, it's usually because you are the sacrifice for a green wave happening on a more important road. The system has decided that making you wait 60 seconds is worth saving 500 people on the cross street 10 minutes of delay. Let's talk about the future now. The next step and what we're seeing roll out in major tech hubs now is vehicle-to-infrastructure communication. In this world, traffic light doesn't just watch your car. It talks to it. Your car's dashboard will tell you that the light will turn green in 12 seconds or to stop down your speed to catch the next green light. Self-driving cars will coordinate with the intersection to merge without even needing to stop. This can potentially even eliminate the need for traffic lights in some zones. We are moving from a system of signals to a system of orchestration. So, the next time you're sitting at a red light, remember, you aren't just waiting for a bulb to change colors. You are a data point in a massive real-time optimization problem. The light is balancing the needs of emergency services, public transit, pedestrians, and thousands of other drivers at the same time. It's a thankless job handled by magnets, lasers, and code. Traffic lights don't hate you, they are just trying to solve a puzzle that has no end. Understanding how the road thinks doesn't just make you a better driver, it also makes you appreciate the invisible engineering that keeps our civilization moving from one green light to another. And that's it for today's video. Let me know down in the comments, have you ever successfully caught a green light? Or do you also think that every single signal in your city is out to get you? I would love to listen to your traffic horror stories, so do let me know in the comments below. Also, if you enjoyed this look at the tech under our tires, hit that like button and also subscribe to the South Era Network for more tech talks with me. As always, thank you so much for watching the video and I will see you in the next one.